Okay, so we saw this float command that we used to convert one side of our division to a float. We're going to be doing quite a lot of variable changing of types, so it's important to be familiar with this. If you convert something from a number with decimal place information into a whole number, Python isn't going to do anything clever. It's just going to forget the decimal place information. So if I do int of 2.1, I get 2 back. You can also, so int is the way of converting a number to a whole number type, to an integer. We've seen that there are integers and there are floats, which are whole numbers and numbers with decimal place information. If you want to convert some data type into a whole number, this int keyword is the way to do it. So if I want to convert the string that contains a 4 and a 2 into a whole number, I do int, I open my brackets, and then I give it the string, and you'll see that what I've got back is the number without the quotes, and now I can actually do mathematics on this number. So if I had a data type that's a string, and I try and do some multiplication, we know that we're just going to get the string repeated, but if I want to actually do maths on that number, I then do int, which will convert it to an integer, and now I can do maths on it. So now it's actually a number. The true and false keywords can be a little tricky. So I'm mainly showing you these to make sure that if you look at someone else's code or get code from the internet, that you're not lost on what they're doing. But 1 is equivalent to true, 0 is equivalent to false. So if you convert 1 to a Boolean, which is the true and false data type, you get a true. If you convert a 0 to a Boolean, you get a false. If you convert a string with anything in it to a Boolean, it's true. If the string contains nothing, it's false. So a string with anything in it, including just a space, is going to be true, which is what this example is. I'm converting this string that just contains a space to a true or false value, and I'm getting true back. Whereas when I convert this string that doesn't contain anything, not even a space, to a Boolean, I get a false back. Don't go using this as your main way of doing true and false in your code, but sometimes you come across people using this, and I don't want you to be lost when you see when you pick this up from other people's code. Mainly, I just want you to be writing true with a capital T and F with a capital F, but it's important to be aware of these examples. So if you convert a number without decimal place information to a float, you'll see that you get the 0.0 on the end as you might expect, and now you're able to do the divisions with it as we saw previously. Okay, so we've seen true and falses. You can actually build up some fairly complicated statements using these Boolean conditions. We're going to use these to decide whether or not to run certain bits of code. So most of the power of programming comes when you have conditional running of code, when you only do certain things if certain criteria are met. For example, if your gene expression is over a certain threshold, or your gene name matches your gene of interest, you might want to do something. So this is how you build up these conditions. All of the standard logical operators you might expect exist in Python. You can check whether two things are equal to each other using a double equal sign. So let's start from the top. If we do 2 minus 1, this means not equal to. So the not equal to will be true if two things are different and false if the two things are the same. So is 2 minus 1 not equal to 1? Well, that's false, because 2 minus 1 is 1, 1 is equal to 1, and so the not equals is going to give you a false. This division is the way you can think of this. All of you that are on Python 2 can think of this as just a single division sign. This is the way of running Python 2 division within Python 3, so to make sure that we're all on the same page. If you do 5 divided by 2, we've seen previously that that just returns 2 with no decimal place information. So if I check whether 2 is equivalent to 2, using the 2 equal signs, I get true back. If you're running Python 3 and you don't put the two slashes there, that would probably be false. So 1 less than 2 is going to be true, obviously, because 1 is less than true. And then you can add these other keywords on to make the statements more complicated. So you can have not, which will convert things that are true into things that are false. You can have and, where if both sides of the and statement are true, the whole thing is going to be true. So here we have true and false. and that overall equates to false because both sides of the AND statement need to be true, whereas true or false gives true because one side of the OR statement is true. So AND requires both to be true, or only requires one to be true. So on this final line, we see something more complicated. Let's figure it out. Let's work from the innermost brackets outwards. True and true. Well, that's going to be true because both sides of the AND statement are true. We then have a not before it, so we'll convert that true into a false. Then we have false or false, and that's going to give false because neither side of our OR statement is true. So overall, this equates to false because we have true and true giving true, the not changing it to a false, and then we have false or false. Can everyone see why that final line gives you a false back? I can see some people thinking it through. Some nodding, some blank looks, but overall, I think people have got it. Great. Okay, so as I say, the reason these statements are powerful is because we can combine them with structures like if statements to decide when we run certain bits of code. So until now, we've seen our code has been running line by line. Every line we type has been run. No code has been ignored. Now, this if statement enables us to check whether something is true or false, and then only do the code if the condition is met. Only do the code if it is true. So we've been going through line by line. When you hit an if statement, it will check some condition. It can be a big, long condition as long as it eventually evaluates to either true or false. If it's true, it will run all the code that's indented underneath it. If it's false, it will skip all that code and carry on with whatever's after the if statement. There are also if and else statements where it will run the code line by line until it reaches the if statement. It will check whether the condition is true. If it is, it will run the code that's indented there. If it's false, it will run the code that's indented underneath the else statement. So here's where these indentations that I talked about being important come in, because Python decides what code to run based on what it's indented underneath. So if the code is indented under the if statement, it's going to run if the condition is true. If the code is indented under the else statement, it's going to run if the condition is false. And then at the end, it will go back to running whatever's after it line by line. So let's see an example. I define a variable called myNumber, set it equal to 5, the same way we've defined every other variable. On the left of an equal sign is the variable name, on the right is the variable value. Then I have my if statement, and the if statement syntax in Python looks like this. We have the keyword if, that has to be if, you can't change that. So then we have if, space, and then some condition that evaluates to true or false. We know that this is going to evaluate to true or false because we have this greater than or equals to sign in the middle of it. So my number greater than or equal to 2. We know that's going to be true if our number is greater than or equal to 2 and false if it isn't. We then have this colon at the end of the line, which is very important. Colon, new line, indentation. You'll notice when you're typing this that the start of the line changes from having these arrows at the start to having these dots at the start. And that's just Python's way of telling you that it hasn't finished evaluating what you've typed in yet. So if you see arrows at the start of the line, it means I've done all your previous code, I'm ready for the next command. If you see the dots at the start of the line, it means you're still typing this command, I'm waiting until you've finished before I evaluate everything. So nothing here is run until we get to the end of the dots and hit enter one more time. So if my number is greater than or equal to 2, colon, new line, indentation, let's print big number. Else, and note the else statement is in line with the if statement. It's very important that you match my indentations and get everything lined up the same way I do. Else, colon, new line, indentation, let's print small number. Now you'll see that blank line at the end. That's because I pressed enter one more time at the base level of indentation. That is me telling Python that there's no more code in the else statement. I'm done typing, and then it will finally evaluate everything that we typed, and you should see big number printed to the screen because our condition was true and my number was greater than or equal to 2. Okay, so here's another example of an if and else statement, this time with a string and with a nucleotide sequence. So if my string called seek is those nucleotides, we might want to check whether our seek dot starts with ATC. Remember, dot starts with will be true if our sequence starts with some letters. So if a string starts with a substring, that will be true. So if seek dot starts with ATC, colon new line indentation, let's print seek. Else, colon new line indentation, let's print no ATC. Now you'll note my print statement here might look a little different. Previously we've been seeing I've always been running print hello world, and here you see I'm running print without the bracket no ATC. Now this will only work with version 2. This will work with all versions. So whenever you see me writing a print statement without the brackets around the quotes, I encourage you to add the brackets like this and be more rigorous to make sure your code is version agnostic and can work with everything. So this is me being lazy. Don't do it. Put your extra brackets around your quotes to make sure that your code can work with any version of Python whenever you see a print statement like this. Okay, so these two examples are exactly the same. The actual if statement is exactly the same. The only difference is the variable that's defined at the start. So for one of the examples, we have a TC at the start of our sequence. The other one, we have a GC at the start of our sequence. And that means the same if statement code actually comes out with different results because of the different variable that we have at the start. Now you'll notice and maybe begin to feel frustrated that you have to retype all this stuff in again and again, and that is the disadvantage of working in this interactive environment. And we'll come across how to write things into a text editor so that we don't have to retype things every time we do something different. But for now, this is a good practice. So if our seek starts with ATC, which it doesn't in this example, therefore the else statement runs and it prints no ATC. So the top example prints the sequence back. The bottom example prints the words no ATC. Can everyone see why those two if statements give different results because of the different variable at the start? That's the real power of these if statements, is that you're able to write one piece of code that produces different things for different inputs. So it might be different genes, might be different data sets, but you only have to write the code once. Once we're working outside the interactive environment, you'll only have to write the code once. But now you have to write it multiple times. Anyone stuck? Okay.